So welcome Marquette, Marina, and Roxy, and Jack, and Sophia, and Jacqueline, Denise, and Liz. Thanks for coming. Let me jump right to the quiz. Okay, so here's the quiz. And it says, according to the Humane Society, 25% of all pets in shelters are purebreds. A researcher wants to see if this is different for those that are at least 1 year old. The researcher looked at 350 pets in shelters that are at least 1 year old, and 107 of them were purebreds. And the question is, state the null and alternative hypotheses for the corresponding hypothesis test. All right, so hopefully you all know when you have a hypothesis that you start out with H naught. Then for this example, what letter goes next?
P.
Yeah, this is a P because the survey question is that dog purebred? And either a dog is purebred or I guess a pet. Is that pet purebred? And either that pet is purebred or it is not purebred. It's not a number kind of thing. So this is not quantitative. This is very much a yes/no question. And when we have a yes/no question, we use the letter P for proportion. So that means P. And then with H naught, it's always going to be equal to. And then what number comes next in this case? Shouldn't be too hard. Yeah, 0.25, because that is what the kind of status quo of pets are, just all pets, not just the 1 year olds and older. So that's going to be 0.25. And then we're going to have the alternative hypothesis, which I like to write as H1. And that's going to be P. Okay. And now what symbol do we need for this alternative hypothesis? Kind of what's the key word? So there's a inequality. My guess is you probably had the right idea. But no matter what, we're going to have an inequality. There's less than, greater than, and not equal to. Those are all inequalities. So which inequality belongs in this particular one? Yeah, not equal to. Not equal to. I think it's worth it for me to pop it in as an equation because it's prettier. Not equal to is easier to get to. There it is. So P is not equal to 0.25. Any questions on the null hypothesis and the alternative hypothesis? When you say tell which one, do you mean whether it's a less than, a greater than, or a not equal to? Is that what you mean by, yeah, so there's a keyword. You always got to look for the keywords, and the keyword is different. So being different is the same as not equal to. Does that make sense? There's always going to be a keyword. It's not hidden, but you have to look for it. Yeah. Whereas if you said, if it is less than, then we have a less than sign. Or if it was more than, it would be a greater than sign. So again, you look for the key word or words that will give you the inequality. Just kind of read through. It's not that many sentences to read, but you got to go find it. And that's very important. Okay, now we find the test statistic and the p-value. Okay, and notice, let me write this out. We have a 0.25. We have a 350 pets, and 107 of them are purebred. So let's go up to the calculator. Which calculator do I use?
Hypothesis test for a proportion.
Yeah, exactly. Hypothesis test for a proportion, which is number 16. And it asks, what is n? And n in this case was 350. It asked for x. X was 107. It asked for P naught, which is the number that is involved in the hypotheses, and that's 0.25. It asked for less than, greater than, or not equal to. Well, our hypothesis, our alternative hypothesis had a not equal to. And I click calculate. Any questions on using the calculator? So notice this number, the Z, is the test statistic, which is 2.4071. So I can write Z is equal to 2.4071. And then the p-value was this number, which is 0.0161. Any questions on finding the test statistic and the p-value?
What did you say was the key word for the is not equal to?
In this case,
Yes.
right here, different.
Okay. Different. Gotcha.
Doesn't the word different mean not equal to?
Right.
Because you could be different by being a smaller percent, or you could be different by being a larger percent, and that's a not equal to, both sides. That makes sense? Yeah, and practice helps. Okay, there's only so many keywords that could ever happen. So if you do a bunch of these, you'll start getting used to them. Make sure you get used to them by Thursday, because that's where the big points are. Okay, use the language discussed in last week's webinar to state your conclusion. Use a 5% level of significance. Okay, what are the first few words always in the conclusion to a hypothesis test?
We can conclude that.
No. It's not the first few. Yeah, there. It
There
really
is enough
helps to know
evidence
that
to-
first word. What's that?
There's enough evidence to conclude that.
But not enough. There
Oh.
is what's the word that we use for our class for statistics?
Sufficient.
Yeah, you could have sufficient. I'll use sufficient. You could also use statistically significant. Those mean exactly the same thing. Sufficient evidence to conclude that. Okay, and now you must refer to the population. If you don't refer to the population, I take points off. The most important on Thursday, that the population proportion of purebreds no A in purebreds, right? In purebreds for pets in the shelter that are at least 1 year old differs from 0.25. Okay. Notice differs because of the not equal to. Notice that it's sufficient because the p-value is 0.01. Okay, 0.0161, which is less than 0.05. If the p-value is small, that means that we have sufficient evidence or statistically significant, however you like to write it. Any questions at all on part C? Okay, then part D. Based on part C, either a type 1 error or a type 2 error is relevant. State which one is relevant and what are its ramifications. So the first question is, which is relevant based on part C?
One.
Yeah, type 1, because we have sufficient evidence. And type 1 is when you have sufficient evidence, but actually your declaration was wrong. Okay, it doesn't mean you made a mistake. It just meant that your sample misled you. Do you see the difference? So the type 1 error is relevant since we had sufficient evidence. All right, so now what are the ramifications of type 1 error? So what damage is done? Okay, no one's going to die, probably. But what might happen? See if you can come up with anything that might happen because of a type 1 error. Any thoughts? I don't see you all jumping in. Okay, you kind of have to, use your imagination a little bit, but the key is to make sure it's relevant to a type 1 error. Okay, if I don't hear it, maybe I'll type some stuff in. So first thing, a type 1 error means that we made this conclusion from part C, that we did say that it's different from 0.25 in terms of purebreds, okay, when it really was 0.25. Okay, that's first what the definition of a type 1 error. So the problem is that we could have, or that, let's say, these shelters will advertise that 25% of their actually will advertise that 25% of the, actually, let's go this way. It really will not advertise that 25% of their older dogs or older pets are purebred. Okay. Because they think it differs, right? So they're not going to be able to say and tell everyone that, hey, 25% of our elder pets are purebred. You can come in and get this special pet. So people won't come in to adopt a pet, may not come in to adopt a pet, but they could have advertised since it is the truth. Okay, and in this case, there'll be pets that are not getting adopted. Any questions on that idea? So you just get creative. Any questions at all on the quiz? This was just a 1-question quiz. I mean, 4 parts, but 1 hypothesis test. Any questions? Okay, if there's no questions, I think I'm going to move forward and talk about the new material. Okay, actually, before that, got to make sure. Are there any questions about anything else besides the quiz? Could be about the project. It could be about the exam. It could be about something else you're working on. Any questions about anything?
Is the exam still out of 100? Because it does say 73.
Okay, so the way it works, it's a Canvas thing, is that Canvas gives you the total points that are on the exam because, if you add up the points from each of the questions, it's 73 total points. But then what'll happen is it'll take the amount of points you got, it'll divide by the total by 73, and it'll multiply by 100, and that's what you'll get. So that 100 is a percent. Does that make sense?
Yeah.
So the highest you can get is 100%, which makes sense. The lowest is 0%. And, I mean, it'd be great if you got 100%, but most people get somewhere in between. 99 would be just fine too. So that's kind of how Canvas works. It's very hard for me to make it worth 100 points. And that's why I do the percent, because, it's just the problems don't like divide evenly by 100 kind of thing. So it's chapter 10 on the exam. So that's a really good question. It's a deep question, actually. So technically, chapter 10 is not on the exam. But look at the first two words of everything we're doing today when we're talking about chapter 10. What do you see? Okay, hopefully you see it says hypothesis test. So chapter 10 is not on the exam, and it's not just hypothesis test, but hypothesis test and confidence intervals. So you won't get anything specifically from chapter 10 in the exam, but chapter 10 will help reinforce your knowledge of hypothesis tests and confidence intervals. So it can't hurt to do chapter 10, but I'm not going to give you specific difference between populations, proportions, or means on the exam. But you will be getting hypothesis tests and confidence intervals because that was chapter 8 and 9. Does that make sense? Okay, so sometimes I say, just wait until the exam's over and then start working on it. But in this case, actually, it will help you to do chapter 10 because it'll reinforce your idea of hypothesis tests and confidence intervals. Because there's not too much new stuff in chapter 10. It's mostly a review. So hopefully that answers your question, does it? Okay, other questions? That was a good question. Okay. And by the way, chapter 10 is on the final exam, which is in 4 weeks from today. Any other questions? Okay, if there's no questions, I think I'm going to get into the chapter 10 material. And as I mentioned, chapter 10 is all about comparison studies, which is what you're usually doing. Most studies are comparison studies. Okay, and sometimes they even get more involved than chapter 10. And that's why we have chapter 11 and chapter 13, it turns out, and even chapter 12. So, we're going to be looking at multiple variables when you're comparing pretty much for the rest of this course. So let's start out by talking about a hypothesis test for the difference between two proportions. And again, there's nothing theoretical that I need to talk about for hypothesis test for the difference in two proportions. It's basically the same idea. We have a couple new symbols. It's going to be a different calculator number, but really it's the same stuff. So I'm going to do this one and the others too by example. I think that's the best way in this case. There's no theorems or anything like that where I have to get into it. So the example I have for y'all is the following. And that is, has a percent of Americans who consider race-related issues the most important problem in the United States changed over the past month? Okay, also interpret the 95% confidence interval. Okay, any questions on the question? Kind of what we might be interested here in terms of the hypothesis and the confidence interval.
Hold on. So just to clarify, we'll only be doing hypothesis testing for one mean or one proportion on the test.
Yes.
Okay, cool. Wanted to make sure.
Yeah, and that has to do with my own kind of personal feeling of what's right and wrong, and that is I don't feel right testing you on something where the homework isn't due until Sunday and your test is on Thursday.
Yeah, I just wanted to ask
Yeah.
because it's
Yeah.
a similar topic, so I wondered if like maybe that was an exception, but
No,
hey.
I don't make exceptions.
No.
No, I don't make exceptions. Oh, but there is an exception about something different, totally unrelated to what you're asking about, nothing to do with the exam. But I should mention this, and that is Friday's office hour will not happen. Okay, most of you don't come to office hours on Friday anyway. It turns out I'm going to be, I'm on an interview committee to hire a full-time faculty member, and that takes priority over everything basically, because if we hire someone bad, then it destroys the college in a bad way for sometimes decades. So hopefully we'll find some really good people to hire. But so I'm on a hiring committee, and so I'm not going to be in my office or my office hour on Friday because I'm going to be interviewing people. Again, so there aren't a lot of times I'll tell you that, you know, office hours are canceled, but that Friday is canceled. But the good news is most people probably won't come on Friday anyway because your test is on Thursday. But I figure I should mention that, that Friday's canceled. And then Monday, there's no office hour, but there's a good reason for Monday having no office. I mean, there's a obvious reason that you should all know about why there's no office hour on Monday. What is that? Nobody knows? Yeah, holiday. Yeah, it's Memorial Day. Yeah, so Monday's Memorial Day weekend. I mean, this weekend is Memorial Day weekend. So Monday, there is no office hour. If you can go find me and ask me a question in the morning on Monday, I will be shocked because it'll involve a 10-mile hike. Okay, actually 20 miles to find me and come back. So it'd be cool if you can find me. But good luck. So I'm going to be out enjoying the weekend. Hopefully you will be too. So just let you know, there's no office hour on Friday because of this interview committee that I'm involved in. There's and then Monday there's no office hour because it's Memorial Day weekend. Okay, so that's just a note. And Sunday, Monday, from Sunday, like Sunday morning to Monday afternoon, I won't even be on. I'll be offline completely because I'll be backpacking. That's what I'm saying. Good luck finding me. I'm gonna be out in somewhere in the middle of nowhere. So I'll be backpacking, and you won't find me. So if you email me, it'll be a while before I get back to you, just on that Sunday, Monday time. So just a note, a heads up. But then Friday is not a holiday. Friday, I'm just going to be in an interview committee, and with interview committees, I can't be there for office hours. Okay. Thursday I have interviews also, but my office hours are Thursday night, and that's after the interviews. But on your test time, I'm going to be interviews. So I'm going to be on and off. I'm going to have the interviews are on computer. So I'm going to have two computers at my desk. One computer, just in case I have a question from you guys that an emergency on taking the test. And the other one doing the interview, just let you know. So if it takes a little while for me to get back to you for when you're taking the test on Thursday, if you have trouble getting in, then that's because maybe I'm asking an interview question. Hopefully that makes sense to you guys. I decided there's no reason to get a sub when there's no teaching on Thursday. Any questions on my schedule? Okay, so we want to find out if the percent of Americans who consider race-related issues the most important problem in the United States, has that changed in the past month? Okay, and do we know Do we know the percent of all Americans this month, this May, who consider race-related issues the most important problem in the United States? Do we know that?
No.
No. Okay. No, we don't know the percent of all Americans, right now, this month. How about last month? Do we know the percentage of all Americans last month who considered race-related issues the most important problem in the United States? Do we know that? No, there's no way. There's no way you can, because you would have to have surveyed everyone in America. And I know personally that didn't happen. My guess is all of you know personally. Am I right? Never had anyone say no. Did they ask any of you? Okay. All right. No one's saying they asked. Again, it's never happened. We have, over 300 million people in this country. Chance of them asking you is like minuscule. Okay. And me too, by the way. So we don't know either. We don't know this month. We don't know last month. We want to compare the two, but we don't know the populations. We can't know. And that's why statistics are necessary. So what we can do, though, even though we don't know, we can write down a null alternative hypothesis. So I'm going to write down using that guy, H naught, colon. Hopefully you're all used to this by now. See, even though chapter 10 is not on the exam on Thursday, H naught colon is. So make sure you know chapter 9, because that's going to be in chapter 9. What comes next is an adjustment of chapter 9, which won't be on the exam. Okay, and the idea here is last week, and even the quiz today, you would have the proportion equal number. Like today, we had P equals 0.25, but we don't know the number last month. Is that clear? And we don't know the number this month. So both of them are going to be variables. So in particular, what I'm going to write down is P sub 1 is equal to P sub 2. And let me write where P sub 1 is the population proportion this month. Okay, I'm not going to write the whole thing, but the population proportion of Americans who consider race-related issues the most important problem in the United States this month. Any questions on that? And P sub 2 is the population proportion last month. Okay. And it does matter which you call this month and this you call last month. You can go either way, but you just have to be consistent and you have to remember which way you went. So that's the important thing. Any questions on H naught? Okay. Now we have H1. The alternative hypothesis. And we're going to have P sub 1. That's this month, remember. What inequality are we going to use for this? And there's a keyword. There's always a keyword that'll help you with the inequality. So what inequality and what's the keyword? And if you see the keyword, then you know the inequality. There should be no question. And it's in the sentence. That's a hint. So there's a keyword in the sentence that tells you the inequality. Yeah, changed. Okay. So with the word changed, what's the inequality? So let me focus on changed. Yeah, changed is not equal to. If it went up, it changed. If it went down, it changed. Do you agree? So that's a not equal to. So P1 is not equal to P2. Let me make it a little bigger so you can see it better. Any questions at all on stating the null hypothesis and the alternative hypothesis for this example? Okay, again, this is very similar to last week, but last week you'd have P equals a number. Now we have a P1 and we have a P2 because there are two unknown that we're comparing. And notice it is a yes or no question. Okay. Yeah, it is a yes, no question because the question is, do you consider race-related issue the most important problem in the United States? And you either say yes or you say no. And when you have a yes, no question, that's P. P for proportion of yeses. Any questions so far? Okay, let me go to the article. So we have an article and I actually made it easier, so I clicked on it. And here's the article. I like Gallup just because they tend to have the sample sizes nicely and they give the statistics, but you know, there's lots of news articles that will show this kind of stuff or other articles. So if we go in and we can see, here's race-related issue is the most important problem facing the United States. Last month it was 12%. This month it's 11%. Has it changed? Went from 12 to 11. Has it changed? What do you think?
Yes.
Okay, you got to be very careful. Okay, the sample proportion changed, but do we know whether the population proportion changed? That's the bigger question. And the answer is this isn't enough information to tell us whether the population proportion has changed. This is where we have to use statistics. So if it's a big percent difference, okay, in terms of using all the stats, then we say it's changed. And if it's not a big percent difference, so in other words, if it's a very, very low probability of that difference happening, at least that amount, then we're going to reject the null hypothesis. On the other hand, if the probability of that change of 1% is not that low, in other words, if those could have been the same, we just collected two samples and they're always gonna be a little different. Okay, and if the probability being the amount difference that we got, which is 1% difference, then you're gonna say that maybe it hasn't changed. We don't have evidence. Any questions on an idea? All right, so just a note, down at the bottom, if I go to survey methods, at least in May, it was 1,016. And I looked this up and it was 961 for last month. Okay, that took a little research, but you can trust me. So let's write this down. So we know that N1, okay, and N1, 1 means this month, was, again, that was 1,000. Oops, lost it. 1,016. And 2, that was last month, according to our notation, was 961. Okay. Notice that we had a 12% last month, 11% this month. Any questions on that? So pretty important to note, that's that 12%. Let's write, oops, this is P, and let's do it this way. Make a hat over it. It's P hat sub, if we want to do the 11%, because that's our first one, then that's P hat sub 1 is 0.11. And then P hat sub 2 was 0.12. Any questions on grabbing the data? Grabbing the statistics that we know? Okay, is the sample size, you think it's big enough? How do you tell? And I want to warn you, I'm not going to be testing you on a sample size for 2 proportions for the exam on Thursday, but it's not any different than 1 proportion, or almost not different at all. Very minor difference. So is the sample size big enough? What do you think? Yes or no? Any ideas? I don't see y'all jumping in. Okay. So first thing, note this is a yes/no question, right? And with a yes/no question, you don't use 30. You use NP and NQ greater than 5. So again, same as what we did last week and the week before. The only difference is now there's 2 NPs and there's 2 NQs. And we got to do both. We got to do all. So we got to do all of them. So let's do them, but they're easy. So notice that N sub 1, P sub 1 equals 1016 times 0.11. And that's more than 10% of 1016, which is more than 100. So that's greater than 5. And N sub 1, P sub, Q sub 1. That's equal to 1016 times 0.89. 1 minus 0.11 is 0.89. And that's certainly greater than 5, much greater. And then similarly, we have to do the same for the other sample. You have to have NP and NQ bigger for both samples. So I'm going to copy and paste and just change what I need to change. So now it's not N sub 1 anymore, it's N sub 2. It's not P sub 1, it's P sub 2. It's not 1016, it's 961. It's not 0.01, it's 0.0012. Or sorry, no 0 there. And similarly, we're going to have an NQQ2, N2Q2. And that is not 1016. It's going to be 961. And it's not 89, it's 88. And that's still, they're all bigger than 5. Any questions on this little bigger than 5 thing? Therefore, we can proceed with the hypothesis test, since the distributions We write sampling distributions. Are approximately normal. Any questions? Any questions on that? All right. Hopefully you know by now. What do you think the next step is? It's always the same order of things. We did it all last week. So after writing your H naught and H1, looking at your kind of stats that you got, checking to make sure that you got a big enough sample size, what do we do next? So see if you can tell me. Yeah, we go to our calculator. Okay, so let's go to the calculator. See if you can guess which calculator I'm going to use. So one of these. We haven't used it yet, but that doesn't mean you shouldn't be able to see which one. Not quite 18. Good try. Hint, it's one of the simplest ones there is in terms of reading it. Yeah, 19. 19 is the one for proportions. We got proportions. We have two proportions. There's a P1 and a P2. So it asks for the sample size. And the sample size for our first one was 1016. For the second one, it was 961. Number of successes, well, we got to figure that out. And the way we figure out is we go to our calculator, scientific calculator, and we take 1,016 and we multiply that by 0.11. Because if 11% said yes and there were 1,016 in the survey, then 1,016 times 0.11 is the number of people who said yes. And then we use the rules of rounding. We need to use the rules of rounding because you can't have a fractional person say yes. So that's 112. Any questions on that? Okay, our sample size was 961. Again, number of successes. That one we got to figure out. So 961 times 0.12. And that is 115.32. We round it to 115. Any questions on getting the number of successes? Okay, our alternative hypothesis was not equal to. So I click not equal to. We're going to want a 95% confidence interval. So 0.95 because that was part of the question too. And I hit calculate. Our test statistic is negative 0.657 or so. Our p-value is 0.51. What does that tell us? If the p-value is 0.51, what does that tell us? So again, even though we haven't had this chapter, if you understood last chapter, it's no different. That's why this particular webinar is kind of a review because it reviews a lot of what you did the last couple of weeks. And if the p-value is 0.51, what do we tell? What do we say? See if you can tell me. It's very important that you can tell me, because on Thursday you need to be able to tell me what happens when you have a p-value of 0.51 for a single proportion or a single mean, but it's the being two proportions doesn't change anything. So what does it tell you when we have a p-value of 0.51?
That if H naught's true, that like, and if the same sample of that size is taken, that there's a 51% chance.
Okay, so that's how you interpret what it means to say you have a probability of 0.51. But what about the conclusion when you see 0.51 as your p-value?
Oh, statistically insignificant or no conclusion.
Yeah, statistically insignificant. I like those words better. So there's statistically insignificant evidence. We fail to reject the null hypothesis. Okay, and this is a giant p-value. Okay, you don't even like dream of doing another sample with a larger sample size, because this p-value is so big, it's, you know, it's not going to happen for you. Okay, if your p-value is close to say 0.05, but maybe 0.06, you'd say, well, maybe we just need a bigger sample. But here you just give up. So let's write down the conclusion given our p-value. And that is, there is statistically insignificant evidence to conclude that, and the good news about doing it on a computer, which you'll be able to do on the test, by the way, is I can copy and paste and change a couple words. Okay, and instead of the percent of Americans, I'm going to say population proportion to really, okay, or maybe all. If you say the word all, then you're emphasizing population. The percent of all Americans, not just the 1,000 or so people that they asked, but all Americans, including you and me and everyone you know that's American. So the percent of all Americans who consider race-related issues the most important problem in the United States changed. Okay, and there's insignificant. That means we basically, in a fancy way, say we know nothing. Any questions on the conclusion? Any questions? Okay, I think what I'm going to do, just to emphasize that it's something you should know, but it's not quite as important. But let's interpret the p-value and the level of significance, and I'm going to say it instead of write it, just to kind of emphasize that the biggie, the one you're going to have to do for every hypothesis test question, is this conclusion. Whereas the interpreting the p-value and interpreting the level of significance, you won't have it more than once on any test. So the p-value is 0.51. So that means that if last month and this month, the population proportion of Americans who think that race-related issues are the most important thing in the United States, then there would be a 51% chance that, and now we have a not equal to, so that we would say that the proportion last month, the sample proportion last month and this month, if we took another 961, or we surveyed another 961 people last month and another 1,016 this month, that there'd be a difference of at least 1% in the percents. Because 11% and 12% is 1% off. And similarly, for the level of significance, we say that if the population proportion of all Americans last month who thought that race-related issues were the most important issue, and this month who thought race-related issues were the most important issue. And if those population proportions are the same, and we took another study of 961 last month and 1,016 this month and surveyed, then there'd be a 5% chance that that other study would end up falsely leading us to conclude that the population proportion of Americans who think that race-related issues are the number one problem has changed from last month to this month. Okay, it's a lot of words. I figured I'd say them, but I want to emphasize that the most important thing is what I wrote. You should understand what I said. But if you can't get what I wrote, you're going to get nailed on the test on Thursday, except that it won't be about comparing two proportions, but similar ideas. Whereas if you can't get what I just said, you'll miss a bit on the test. One part of one problem only, instead of maybe a part on several problems. Any questions on this hypothesis test? Any questions? Okay, do you agree this is very similar to what we did last week?
Yes.
Yeah, it's very similar. So again, this should help you for the exam. But don't do a comparison study on the exam on Thursday. Just note, it'll just be a single proportion because that's my promise. But it's going to be similar wording. Statistically insignificant or statistically significant. Those words are going to come up on the exam because that was one proportion also and one mean. Okay, let's do the next example. Okay, and unlike the last example, I'm going to do a disclaimer on this one. And this one, I just made up the numbers. So please don't quote me as some, important study that was done. But a study could be done. Whereas the last one, I grabbed Gallup's poll. So those numbers were, scientifically done and all that. This one, I just made it up. And that is, do single women spend more time cooking than single men? Maybe true, maybe not. Okay, the 35 single women who were surveyed averaged 58 minutes a day cooking, and their standard deviation was 12 minutes. The 38 single men who were surveyed averaged 46 minutes a day cooking, and their standard deviation was 16 minutes. What can be concluded at the 5% level of significance? Also interpret the 95% confidence interval. Oh, you know what I forgot? I forgot to do the confidence interval. So let me just quickly do the confidence interval on this last one, and then we'll go back to this problem. So notice the confidence interval was between about negative 0.04 to 0.02. So let's write that out. And now let's interpret it. What are the first words on interpreting the confidence interval? Same as last week, so important for the exam. What are the first words on interpreting the confidence interval? Or sorry, same as 2 weeks ago, sorry. What's the first word? That'll get you started. Very important. Not if. That could be for interpreting the level, but not the interval. Yeah, with 95% confidence, the population proportion of Americans who And again, we're comparing this month to last month. And when we have our first one, it's always first minus second. So if first minus second is negative, then that means that the first was smaller. So who think that, and let's write out, actually, instead of think that, let's go consider, because that's how the wording is. Consider race-related issues, most important problem in the United States. This month is no more than, oh, sorry, is, so we get a negative. If you get a negative again, that means last month was bigger. Okay, is less than, or at most, 4% less than. Now I just copy and paste, change this to last, maybe change a little grammar. Then the population proportion, let's go the population proportion of Americans who considered, because it was last month, race-related issues, the most important problem in the United States, last month. And basically we do the same thing, except now it's more instead of less and a different number. So I can copy and paste again. The population proportion of Americans who consider race-related issues the most important problem in the United States this month is at most 4% larger than, and it's 2% now because that's the other side, larger than the population proportion of Americans who consider race-related issues the most important problem in the United States last month. Any questions on the confidence interval interpretation? When you have a negative and a positive, it's a little harder to say because you got to say it in two pieces. It's really hard to say it in one. Because it's really hard to say. You don't say between negative 4% and positive 2% more, because no one says negative 4% more. That's just silly. That's why 4% less. If they're both positive, then it's you only have to have half of what I wrote. And you say between those percents more. If they're both negative, you say between those percents less. Any questions on this confidence interval interpretation? Okay, now let's go back to this question. And that is, again, do single women spend more time cooking than single men? We have the sample. What we can conclude at 5% level of significance. Also interpret the 95% confidence interval. How is this question different than the last one? What's the main difference in terms of statistics? What's the main difference in this one and last one?
Mean?
Yeah, this one's all about mean. I'm gonna change your grammar a little bit, but means, because there's two means, right? Whereas last time was proportions, right? So these are means because the survey question is how many minutes a day do you spend cooking? Okay, and I spend 83 minutes a day cooking. It's a number, not a yes, I cook. It's how many minutes do you cook? Any questions on that idea? Okay, so that's the first thing, is it's means. All right, so that means that when we're writing down our H naught, what letter do we use?
You?
Yep, now we're going to do mu. And I'm going to do the following. I'm going to write mu just to kind of show it real well. Sub M for men equals mu sub W for women. Any questions on that? And then H1, sorry. Okay, and if I use M and N, then I don't think I need to spend a whole sentence. I mean, M and W, I don't think I have to spend a whole sentence explaining what they are, because hopefully it's clear. Whereas when I use P1 and P2, you kind of need to explain what they are, because it's not clear which is which. So if you use subscripts that give you what it's about, it reads better. Does that make sense? All right, so H1, we're gonna have a mu sub M. And what is the inequality? Oh, you know, I probably should go in the other direction because we talked about women first. So I should probably put women first. It'll be a little easier to understand. Because in the wording, it's women, then men. So what's the inequality? And what's the key word? There's going to be a key word. And then based on that word, what is the inequality? And it's in the question.
Greater than mu sub M.
Yeah, it's greater than. And what's the key word? In the question?
More.
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 So notice we have this word more. More is a greater than sign. So you got to read the question and find that key word. Again, I don't give trick questions. They're there. You just have to look for them. It's not hidden at all. So it's more than or greater than mu sub W. Oh, sorry, M. There we go. Any questions on H0 and H1? Okay, now I want to mention something, and this is very important for this chapter. This is 35 single women, 38 single men. They don't have anything to do with each other. Like that first woman has nothing to do with the first man. Do you agree? It's just a group of women and a group of men. Nowhere in here does it ever imply that there's any kind of pairing up between these men and women or women and men. Do you agree with that from reading the question? So what we say is they're independent of each other. Okay, this is an independent hypothesis test, or a hypothesis test for independent means. It's very important. Had we looked at, say, instead of single men and single women, had we looked at married couples, and we looked at 35 wives and their 35 husbands, then they're paired up. And then that first wife would be paired up with the first husband. And then we do something very different. And then we do what we can do in the last example that we haven't gotten to yet. Okay, so these are independent samples the way that this question reads. Any questions so far? Okay, so now that we have our hypotheses, can I use this calculator, the two proportions calculator? Will that work? So can I use the two proportions calculator? Don't see y'all jumping in, but you should. Any thoughts? You can at least guess. So will this calculator work for us for our example we're doing right now?
Yes.
That's a good guess, but we're not looking at proportions. Our H naught is mu W equals
Yeah.
mu M. Means, not proportions. So this is a no because we're looking at means. We're not looking at proportions. Does that make sense? Very important to get those two straight and make sure that if you're talking about means, don't go to proportions. If you're talking about proportions, don't go to means. They never mix. So we need to go back to our calculator menu and find the right calculator. And what calculator we're going to use.
Um, 18.
Yep, this one's 18 because we have independent samples and we have statistics. So I click on that. And it asks us for the sample size for the first sample. And again, there were 35 single women. So that's 35. It asked for the second sample size. There were 38 single men. So that's 38. It asked for the sample mean for the women. And the sample mean for the women was 58. It asked for the sample mean for the second sample. That's for the men. Sample mean for the men was 46. The sample standard deviation for the women is 12. The sample standard deviation for the men was 16. Our H naught had a greater than. H1 had a greater than. So I go to greater than. We wanted a 95% confidence interval, 0.95. And I hit calculate. Any questions on using the calculator? Any questions? Okay, notice we have T for our test statistic. It's the same students T distribution that we had the last couple weeks. Okay, I'm not going to get into the mathematical details because it's brutal, but you can trust me that you still have a T distribution. We have a p-value of 0.0003 or so. Tiny p-value. All right, so what I'm going to do now, it's 5:05. Let's take a 5-minute break. And when we come back, then we'll write down our interpretations. So I'm going to take our little break. So I always like to do that around now. Okay, welcome back. It's 5:10. So let's get back to the question we were looking at. And the important thing is this p-value, 0.0003. What does that tell us? So at the p-value 0.0003, what's the conclusion?
Statistically significant.
Yeah, statistically significant, because it would be very, very unlikely had they had the same population mean number of minutes per day cooking for us to do a study of 35 women and 38 men and have such a difference. Okay, so when it's so unlikely for what we got to have happened, you say, well, something went wrong. And what went wrong was the means are not the same. In particular, the women are spend more time cooking than men for single men and single women. Okay, and I want to mention again, I made up these numbers, so but it could be done. You could do a study like this. All right, so let's take a look and let's interpret. We can say there is, and when you have less than 0.01, you typically use the word strong, statistically significant evidence to conclude that the population mean number of hours, or number of minutes, single women spend cooking per day is greater than the population mean number of minutes that single men spend cooking per day. Any questions on the conclusion? Okay. Any questions? Okay. Notice if you want to interpret the p-value, you would say that if the population mean number of minutes that women spend cooking per day was the same as the population mean number of minutes that men spend cooking per day, and if we surveyed another 35 women, single women, and 38 single men, then there would be a 0.03% chance that this new study would have the sample mean number of minutes for women cooking per day at least 12 minutes longer than the sample mean number for men cooking per day for the two samples. Notice 12 minutes because 58 minus 46 is 12. Any questions on that? Okay, and then if men and women have the same population mean number of minutes spent cooking per day, and we conducted another study, 35 single women and 38 single men, then there would be a 5% chance that we would end up falsely concluding that the population mean number of minutes that single women cook per day is larger than the population mean number of minutes that single men spend cooking per day. Any questions on those interpretations? Any questions? Okay, I have one more example. And this is an example that literally made me thousands of dollars. Okay. And not for my salary or anything like that. But any guess on how I made thousands of dollars?
The stock market.
The stock market. So let me tell you something I do. And, I recommend you guys do it too, but it does take some work, is that I look for patterns. Okay. I look to see, is there something that other people aren't noticing that's happening that I can see, and it's kind of a trend and it keeps happening. And then once I notice that other people aren't noticing and I'm noticing, that's when I invest money. Okay. That's what I call play money, which is very different than like investing for my daughter's education. This is money where if I lose money, it's not the end of the world or anything. I didn't put, $500,000 in or something. Not that
I have a
think.
question.
Yeah.
This is sort of off topic, but now that we're on like stocks, would you recommend cryptocurrency?
So here's my feeling about cryptocurrency. It's gambling. Because it's not, cryptocurrency doesn't make anything. Does that make sense?
Yeah,
Okay. And I'm not gonna spend a lot of time because it is off topic.
right.
So it's like whatever the mood swing is, it's really hard to know. Does that make sense?
Yeah, gotcha.
Okay. Whereas, so now let me give you my example. In NVDA, which is NVIDIA. Anyone heard of NVIDIA? They're a chip company. Gaming chips. Chip not as in like eating chips, but computer chips. Okay, so NVIDIA stock. So let me tell you what I noticed. And this happened a little less than 4 years ago. I noticed that the president we had at that time, hopefully you remember, one of the things he liked to do, what Trump liked to do, was tweet. Okay. And if you don't know that, then you were just like not even noticing the news ever. So he used to tweet all the time. And what I noticed is that when he tweeted about China and needing to do something and, punishing China for whatever he wanted to punish China for, because he did that a lot, that the stock market would go down. Okay. It was very consistent. And then within about a week later, the stock market would go back up to what it was before he tweeted. Okay. Not always, but it was pretty much happened pretty much every time. Okay. How much it went up, that would change depending on the week and stuff. But I noticed it happened. And I noticed that no one seemed to like pay attention to it. They all talked about his tweets, but no one talked about the stock market. So I went and looked at stocks and found out NVIDIA seemed to be the most reactive to Trump's tweets. So then what I did is I went and I looked at the data. And before I did that, because I said I think that NVIDIA is reactive, okay, then here's what I did. I set up my hypothesis. And what I'm looking at is what I call the stock market price on tweet day, okay, which is the day that Trump tweeted about China, and the stock market price 1 week after he tweeted, okay, because tweet day, the market always went down. That's what I noticed. So I need to write down my null and alternative hypotheses. So I'm going to write H naught. Hopefully you're all used to H naught. Okay, that's important. You need to know how to write H naught colon for the exam on Thursday. That's going to happen. Okay, I promise. Okay, so we have H naught colon. And then this is different than the last example in the following way. For each tweet, there's two numbers. There's the day of the tweet and the week and 1 week after that tweet. And I'm pairing those two numbers because for me, that's going to be my buy and my sell. Does that make sense? So for every tweet, I get two numbers out of it. And when you get two numbers out of each instance, that's dependent data. Whether it's two numbers from a tweet or whether you're going to be asking two survey questions of a bunch of people, like, for example, I don't know, something like how many days a week do you go out and eat at a restaurant? And how many days a week do you do a physical activity, exercise? Okay, well, notice that would be two answers from the same person, both numbers. Okay, similarly, the stock has two answers to each tweet. Okay, so sometimes it's by day, sometimes it's by person. Sometimes there's all kinds of different two answer kind of studies. When you have these two answer studies, we call that dependent data. And it's quantitative, so it's dependent means. So what I'm going to write is the following. I'm going to go mu, because it means, sub d equals 0. Any guess on what d might stand for? Hint is it's the first letter of a math word. Nothing too fancy math word. Math-ish. You guess?
Decimal?
Huh?
Decimal?
It's a good guess, but this isn't anything about decimals, right? What are we looking is 106 and 113. We have two numbers.
Division.
Okay, that's one idea, but division would be too complicated. Easier than the division. Difference. Okay, we're subtracting the numbers. So what we're going to do is we're going to look at the differences. And for each of these two outcomes, we're going to find the differences and we're going to find the mean difference. And we're going to say that if tweet day and 1 week later were the same, then the mean difference should be 0. Is that clear? On the other hand, let's see what we want. We have H1. And H1 is mu sub d. It's not going to be equal 0, but I'm going to copy it and paste so I don't have to type as much. What inequality goes in between the mu sub d and the 0? What do I want? I want to make money. That's a hint.
Greater.
Okay. That's one idea, but I want tweet day to be smaller than 1 week later. Do you see that? So it's the first minus the second. So I want the tweet day to be smaller, and if it's smaller, then if you subtract, you get less than 0. Is that clear?
Yeah.
And there's our hypotheses. Notice this is different than the last example in that this is dependent data. We just have a mu sub d. Turns out to be one variable, but it looks like 2 and it becomes 1. Okay, then I can go to my calculator. So let's do it. This calculator won't work. So let's go back to the calculator menu. Which calculator do you think I need?
To depend 20.
Yep, number 20, 2 dependent samples with data. So I click on that. Okay, and I need to put data 1 and data 2. So if you remember data 1, our first table, it's kind of messy, 106, comma 110, comma 115, comma 122, comma 114, comma 116. And then our second, 113, comma 124, comma 120, comma 118, comma 127, and comma 128. Any questions on that? Okay, I want it to be greater. Sorry, I want it to be less than. First less than the second. And I'm going to go for a 95% confidence level, or 0.95. And I hit calculate. There's our test statistic, negative 2.8. Our p-value is about 0.02. Then we have our lower and upper bound for the confidence level, for the confidence interval. All right, our p-value is 0.02. What's the conclusion?
Statistically significant.
Right, statistically significant. Notice not strong because we're not under 0.01, but it's statistically significant. Okay, and we had a tiny sample size. By the way, why do you think I had to have a small sample size?
Just for ease of writing numbers in.
Nope, no, this is real. If I waited until he tweeted about China 31 times, then I wouldn't. At that point, it's too late. Then he loses and Biden's in office, and Biden doesn't tweet. So I couldn't make any money. Does that make sense? So there's sometimes you have to have a small sample size, and this was one of them. Okay, this wasn't about convenience. This was about otherwise I'd wait too long and Trump's out of office and I can't make money on him. Okay. And by the way, this is not saying I like Trump or didn't like Trump. I just look for ways of making money. That's all for the stock market, that's what matters. So I can say there is statistically significant evidence to conclude that the population mean stock price 1 week after the tweet, after Trump's tweets, is higher than on the day of the tweet. Any questions on this? Any questions? Okay, and by the way, if you come up with a statistically significant evidence, what do you think I did? Should be obvious, because it's the whole point of doing these kind of hypothesis tests. Any thoughts? I don't hear you. Okay, waited till his next tweet. His next tweet, I bought stock. I waited a week later and I sold my stock. And then I waited till the next one. I kept doing that for a couple of years. And I don't even know if there was any time where I didn't make money on it. I think I always made money. Okay, and if you find patterns that other people haven't found, you can make money. Okay, I'm watching Biden. I haven't found one yet. Doesn't mean it won't happen, but every president has their way, and sometimes you can make money on them. So I'm waiting on Biden. He doesn't tweet, so that won't work, but other things he does. So maybe I'll make money on Biden, in the next year or two. Okay, so that's just a suggestion. If you want to kind of make money that way in the stock market, that's one way of doing it. There's the short term, so day trading kind of stuff. It's kind of like day trading. Any questions on this example? Okay, and the confidence interval, by the way, is about 15. Let's go 14. Let's go negative 15 to 0.7. Okay, actually, let's go 2 decimals. So 1496 to 0.70. Since it's money, that way we can do dollars and cents. So what we can say, they're both negative. That makes it a little easier. with 95% confidence, we can conclude that the population mean difference or population mean stock price 1 week after the tweet is between 70 cents or $0.7, same thing, 70 cents and 1496 higher than it was or it is on the day of the tweet. Any questions? Any questions on this? Okay, and again, buy low, sell high. That's how you make money. Just let you know that. Any questions at all on this example? Okay, if there's no questions on the example, let me get to what we should be thinking about for the next 48 hours, which is
The exam.
yeah, the exam. Okay, so let's think about the exam. Let's talk about it. So the first thing about the exam is everything is the same as the call it the structure and rules are the same as exam 1. So you've already been through it once. Okay, whether you liked it or not, it's what we have to do. I wish we could be back in class. I asked last week if we can do a test on campus. Do you know what they told me? So I asked my dean, my boss. You know what she said?
No.
She said no, because I was hoping I could talk to you and say, hey, though you could take it online or you can come to campus. I'll be there and I'll hand you the exam. And she said no. So sorry. So please don't shoot the messenger on this one. I don't have any choice. Okay, I would much rather do a paper and pencil exam, but we can't do that because of college rules with COVID, and hopefully you understand that. But again, it's not under my control, so don't get mad at me on this one. But next year we're going to be fully open, by the way. So just so if you have other classes next, in the fall, then they'll be face-to-face at our college. Okay, you can take online classes, but we're also going to have fully face-to-face in pretty much all of our classes. Okay, so that's just a note. So the exam is 3:30 to 5:50, same time, and it's Thursday. I will be checking in at the beginning only. There is no Zoom, so hopefully you all get in. If it says, if you click on the exam, you say start the exam, and it says you need an access code. What does that mean you need to do? Because I know it happened to a few people last time.
Email you.
Nope, that won't help at all. You could email me and I'm going to tell you what I'm about to tell you, which I told last time too. Remember? It means that you close your tab, reopen it, and try again. Sometimes it takes 2 or 3 tries. And I can't do anything about that. There is no access code for this exam. It's some weird thing about Proctorio, and I have no control over it. So sorry about that. I'd say about 20% of the students have access code issues. And I'm not there with you, so I don't even know what it is that's going on. Other than what I've learned is that if you turn it off and turn it back on, for most everyone that works. So that's just a big note. Hopefully no issues. again, I'm going to be giving interviews on Thursday. So, but I'm going to have 2 computers in front of me. So if you email me, if you do have a big problem and it's not an access code issue, but something else, you can email me. I'm not there with you, so I can't really like touch your computer and like walk you through it because I'm not there. Does that make sense? And you can't have Zoom on while you're going in. Okay, you should just have your single tab and that's it. You click on it and that's it. So that's just a note. Proctorio is just kind of a little bit of pain. So that's the first thing, is note that. Just like the last exam, you are allowed to bring an index card. So you can put anything you want on the index card. It's totally up to you. Some things you definitely want to put on unless you've got it memorized. And that is that the central limit theorem tells you for means, we have x bar tilde n, right? In other words, the sample mean, the sampling distribution for sample means is approximately normal with mean mu and standard deviation sigma over the square root of n. And for sums, that's the capital sigma, is approximately normally distributed with population mean mu times n and standard deviation sigma times the square root of n. I recommend putting those on your note card. Those are really the only formulas for these 3 chapters. Any questions on that first? Okay, and then anything else that'll help you, put on your note card. Whether it be kind of example problems or templates or definitions or whatever will help you is what you should put on it. Any questions on the note card? And front and back is fine. Any questions? Okay, let me go through what you're going to see on the test. Okay, not word for word, but idea for idea at least. So the first question is exactly the same as the first question on the last exam. Do you remember what that was? And if you don't get the first question right, I give you a 0 on the entire exam, by the way. So what was the first question?
Name.
Yeah, put your name down if you agree not to talk to anyone except children, if you have a child, and not to use any other devices or materials other than what I've already told you is allowed, which means that you're allowed to have a card. You can bring blank paper if you like to jot things down. But the problem with blank paper is that I won't see your blank paper. So you can't get partial credit for what's on your blank paper. So really you want to do everything you can, if possible, on the computer itself so that I can give you partial credit. So really the main thing is you need to bring your note card. Okay. So that's number 1. So you need to basically say that you're not going to cheat. That's all that is. 2 through 7 are true false questions. Okay. Where have you seen true false questions in this class? For the last 3 chapters.
Mark?
Yeah, on the homework. Okay. I call them the exercises because in these days, the word homework doesn't really work anymore because everything is homework. You're doing homework right now by listening to me because you're probably at home. You might not be, but you're probably at home. So I like to call it chapter exercises. So the chapter exercises had true falses. I wrote those, by the way. So that's the kind of stuff I write. So make sure you know how to do those. Okay. And I want to mention, just like on the first exam where you had the true falses, they're not worth as many points per true false as the rest of the questions. So don't spend all your time on problems 2 through 7. Those should go pretty quickly. I wouldn't spend more than 15 minutes on all of them combined. Does that make sense? Okay. So then once you're done with the true false questions, then comes number 8. So number 8 is going to have a paragraph, which I'm not telling you what the paragraph is, but there'll be a paragraph. And then I ask 4 questions. And the first question is state the null and alternative hypotheses. Okay, so already you know what chapter this comes from. What chapter is this going to come from? Number 8? Yeah, this is chapter 9. And you should know some of the symbols, okay? Okay, I tell you, what are some of the symbols that you know are going to be the answer to question 1? There'll be points just for those symbols. That every null and alternative hypothesis has those symbols. So what symbols will you know are going to be there? Hopefully you all know. We did them again today because they're in every null and alternative hypothesis. Yeah, the symbols. So Jack, you missed one of them actually. So it's H, you got to have a colon. Don't forget the colon. You're going to have H naught, colon, and then stuff. And then you're going to have H1, colon, stuff. Okay? And you might have a mu, you might have a P, you might have a less than, you might have an equal, you might have a greater than, you might have a not equal to. On the H naught, you're definitely going to have an equal.
Will we be marked down if we don't use a colon?
Yep.
Doesn't that seem a little pedantic?
You know what? It's the same way, but you can be marked up if you have the symbols correct, even if you like switch mu and p or something. Yep, you need to write down the way it's written down. Okay.
Still, that seems a little.
Okay. Well, it is what it is. Okay, it's the rules I'm making. So I want you to get used to standard notation. That's what that is. And that standard notation is, it's not my notation, it's standard statistical notation. And that is part of this course. Okay. Then the next question. Yeah, the colon is after, well, it's either after 0 or 1, actually. Yeah. So it's not after the H, it's after the 0 or the 1. Because it's like H naught, colon, not H colon not. And same thing, it's H1 colon or HA colon, you choose whatever you like. Okay. Number 2 is find the test statistic and p-value. And so as you can guess, there shouldn't be any big surprises on this. How are you going to find the test statistic and p-value?
Calculator.
Yeah, the calculator, the embedded calculator. By the way, if you find it in some other way, using some very strange way that you shouldn't even have access to, I know you're cheating. Does that make sense? Because the calculator is the only way you can do it without cheating. And it's not hard. I've been showing you how to use a calculator the whole way. It's not hard, but if you paid someone else to do your exam, they probably won't know how to use the calculator. Just let you know that. And I've seen it happen, and it's not good for the student. Okay. So make sure you're not cheating. Don't pay someone else to do the problem for you, because they're going to do it differently. Because I wrote the calculator. The calculator is not known by everyone in the world. Okay, just a note. Okay, then write your conclusion in the context of the study. Just a note. What is the first word for the answer to question 3?
There.
Hmm?
There.
Yeah, there. Okay. You can stick that on your note card if you want. You better get that. You better not have the word if on number 3. Got it? Okay. Because then I'll know that you're just confused. Because that means you didn't answer the question. So I'm telling you, the conclusion means there. And what's the second word, by the way? Is. Yeah. And then the third word, you have a couple choices, but the one I've mostly done is statistically. Yeah. And then it might be significant. It might be insignificant. I'm not telling you now. It's going to be one or the other. Evidence to conclude that. And then the rest is context of the study. And note, context of the study means context of the study. So, for example, in the one we just did, okay, I have the word stock price. That's context of the study. Does that make sense? And tweet. Don't just give me the definition. You need to put it in the context. Okay. And by the way, it's not going to be stock, price, and tweet. So don't just memorize this example. But I'm just letting you know that context means context. Okay. It's about the study itself. Okay. And then number 4, I'm just going to let you know I'm being a little vague. It's a question about type 1 and type 2 errors. So you should understand type 1 errors. You should understand type 2 errors. You should understand how they're used. You should understand how they might give you a level of significance, what the ramifications of each are, and all about the context also. Any questions on question 8? Okay. Question 9. Okay. Number 1, same question. State the null and alternative hypotheses. There'll be a paragraph. Number 2, write down the test you're using, calculate test statistic and p-value. Okay, so similar. Number 8 and 9 are very similar. They're both from chapter 9. Number 3, use a complete sentence to state your results using the content in the context of the question. First word on number 3. First word will be
There.
there. Okay, that should help you. I want to get you started. If you get started, you have much better success than if you don't even know how to get started. Number 4 is the level of significance. 0.05 represents a probability. Use a complete sentence to interpret this probability in the context of the study. What's the first word on number 4? See if you remember. It's been a little while. If. Okay. Again, put it in your note card so you get the first word right, and then it'll at least get you started. I want to get you started. Don't make a mistake on the first word, at least, because you can put that on a note card. Any questions on number 9? Okay. Sorry, there's a 5 also. And the p-value represents a probability. Use a complete sentence to interpret the probability in the context of the study. What's the first word on number 5? Yeah, that's an if again. Yep. Okay, but 5 and 4 are not the same, by the way. So get used to them. Practice. Number 10, I'm just going to say it's a sample size question. So what I've found is that the hardest part that people have trouble with, and it shouldn't be that hard, is knowing which of the sample size calculators to use. There's a sample size for a mean. There's a sample size for a proportion without a preliminary estimate, and sample size with a preliminary estimate. I'm not going to tell you which one. It's going to be one of those. And you're going to have to do that. Number 11. First is come up with the appropriate 95% confidence interval. Then it's interpret the confidence interval in the context of the study. What's the first word on number 2? What's the first word on number 2?
With.
Yeah, with. Get that right.
With.
It'll get you started. It's with. Okay. Number 3, 95% represents a probability. Interpret this probability in the context of the study. Okay. How does that one start? I know it's been a while. This is now we're in chapter 8. So it's been a couple weeks. Yeah, that's an if also. And I'm going to let you review it because we're kind of running out of time. Number 12 is for each. A, write down the distribution. B, answer the question. C, decide if the assumption that the blank normally distributed is necessary for your calculations. So I want to let you know, I want to ask you, how many different things are you going to have to do per part on number 12? And I'll tell you there's 2 parts on number 12. There's a 1 and a 2. How many different things are you going to have to do for number 1? How many different things are you going to have to do for number 2? It's not a trick question, by the way. Should be very obvious. 3, exactly. There's an A, a B, and a C. Okay. Don't just do part B and think you're done. You have to do A, B, and C, or you lose a lot of points. So you need to, when I say write down the distribution, what symbol from your keyboard will be in there? You can put in the chat box because you can actually type it. And the hint is not a letter, it's a symbol. What symbol must be on part A? I know it's been a couple weeks, 3 weeks. Yeah, tilde. Don't forget, that'll help you. Okay, there's going to be a part 1 and a part 2. Both are going to have a tilde. Part 1 with the tilde, part 2 with the tilde, and they're different. Okay. Any questions on that? Okay, and then finally, number 13 is another confidence interval. Come up with a confidence interval, use a complete sentence to interpret the interval in the context of the study, and then was the sample size large enough in order to use a normal distribution? Explain numerically. Note that you have to do it here, and you have to do it here. That normal distribution is important. That's central limit theorem. And how do you tell if it's 30 or 5 is a key number?
Five with the proportion and 30 with the mean.
Yep. So if it's a yes, no survey question, talking about proportions, then NP and NQ greater than 5. If it is a quantitative question with means, then it is N greater than 30. Don't get them confused. You lose points if you get them confused. Okay, keep that in your head, put it in a note card, whatever it takes, so that you get that right. Okay, and then that's it. That is the exam. So then you hit submit, don't forget, and then you're done. And I'll grade it. I'm in interviews all day on Friday, so I'm not sure. Usually I always get it graded within a day. It might be 2 days on this one because of these interviews I'm in, because we're hiring a faculty member. So sorry about that. It might be 2 days. I don't like to make you wait 2 days, but I may have to because I might have time. I'll see. Maybe someone will cancel their interview and I'll have a little extra time to grade. So I'm going to stop the share. And I'm going to stop the recording.